Hello, my name is Michal Kucer, and I wanted to welcome you to our presentation about DeepPatent, a dataset for large-scale pattern drawing recognition and retrieval. In our talk, we will first discuss the challenges with pattern drawing retrieval. Then we will highlight the data domains that we work with, more specifically freehand sketches, pattern drawings, and natural images. Further, we discuss the DeepPatent dataset we collected for training models for pattern retrieval. After briefly outlining our retrieval approach, we will talk about our results and conclude our presentation. As it turns out, pattern search still poses a challenge to modern search engines. Neither Google nor Baidu did succeed in retrieving semantically meaningful results when we used a pattern drawing of a cactus-shaped candy as a query, seen on right. In this slide, we show the retrieval results from Google on the left and Baidu on the right. In our work, we primarily work with the following three data domains: freehand sketches, pattern drawings, and natural images. From the sample images, we can see that pattern drawings are like freehand sketches in that they lack background, are abstract, and sparse. However, they are more detailed and of higher quality, making them more like natural images. Furthermore, we will show that despite the similarity between patterns and freehand sketches, models trained on freehand sketches do not generalize well to pattern diagrams. In this slide, we provide a brief overview of the dataset. The DeepPatent dataset consists of a total of 350,000 public domain images from over 45,000 unique patents collected from the US Patent and Trademark Office. Our collection focuses on design patents, which capture visual characteristics and aspects of an object. One of the main benefits of design patents is their viewpoint diversity, providing us with multiple views of the same object. In this slide, we briefly outline our approach to pattern image retrieval. Our approach leverages state-of-the-art approaches for image retrieval, as majority of the techniques for freehand sketches use both image and stroke information to generate their representations. Our retrieval network is based on the ResNet architecture, where the pooling layer is replaced with a generalized mean pooling layer. Our retrieval model is trained in two stages: a classification pre-training stage and a representation learning stage, where we compare the performance of the triplet and contrastive losses. In the following slides, we give a preview of our results. Our first set of experiments focused on ablation studies. We saw that an ImageNet trained network provides surprisingly good baseline features for pattern retrieval. Classification pre-training further improved these features, and for both ResNet 18 and ResNet 50 architectures, the triplet loss learned better features for retrieval. Our plot on the bottom further highlights the challenge with pattern image retrieval. Increasing the size of the database results in a 14% drop in top 1 retrieval accuracy. In this slide, we compare PatentNet, our best performing model with more traditional computer vision approaches, and sketch-inspired deep learning models. As we can see, PatentNet outperforms other approaches when trained on fine-grained associations from the DeepPatent dataset. Furthermore, we see that PatentNet based on the ResNet 50 architecture outperforms SketchNet architecture, which is a popular baseline model for freehand sketches. In this slide, we show qualitative examples for retrieval results for PatentNet. Top shows a successful retrieval result of a watch. On the bottom, we show an example where we failed to retrieve relevant results, though we can see that the top 3 retrieved results are similar in their circular shape to the query. To conclude, in this presentation, we introduce DeepPatent, a dataset for large-scale pattern recognition and retrieval, discuss our approach to pattern retrieval, and experimental results. If you have any further questions, please stop by our poster.